All right, everybody, let's talk about number 69. And number 69 is simplifying a fraction, multiplication of two fractions, where you have variables being raised to powers. Now, I've written this problem twice because there's a long way to do this and a short way to do this. The yellow is going to be the long way, and the green is going to be the short way. Now, both of them are equally valid, but the yellow way gets really, really clunky when the powers get big. But I'm going to go ahead and show you what that looks like. So this will be the long way of solving this. Now, the first thing we would do is look at each of these things as being raised to a power and say, what does that actually mean? So x squared means x times x, right? So I would write x squared times y as x times y. And then 3y cubed, x cubed would be 3 times y times y times y times y. Ooh, no, there's only 3 y's. Times x times x times x. And that's going to be multiplied by 18 x, 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 x. And then on bottom, x, y, y, y. Why do I have to write so many y's? Like that. Now, when you're looking at fractions and multiplying them, first of all, any fraction that has a common factor on top and bottom should be able to be simplified by canceling that factor. So if you look at the first fraction, we've got an x on top and an x on bottom, another x on top and an x on bottom, and then a y on top and a y on bottom. So what I really have is everything on top and away, which leaves me with a 1, and a 3 times y times y times x. In the second fraction, I have x's on top and bottom that'll cancel, and that's it. So 18 times x times x times x, and then all those y's again. Now, here's the second thing. When you multiply two fractions together, you multiply straight across now, which means the 18 times x times x times x would end up on top, and all that stuff in the bottom would end up on the bottom of a fraction where I multiply. But instead of writing all that out, which would take a little while, I'm going to think about this. Once I multiply these together, the stuff that's on top is going to be on top, and the stuff that's on bottom is going to be on bottom. So I'm just going to write this as one fraction where those things are being multiplied. And that allows me to now start simplifying again. So I have an x on top and an x on bottom. And then that 3 and that 18 will simplify. 3 goes into 18 6 times. So what I have now on top of that fraction is 6 times x times x. And on the bottom, y, 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 y. 1, 2, 3, 4. Yeah, that's 8 y's. So y to the 8. And there's the simplified way. Now, like I said, this works, but it's a long way. And the better way of doing it is to use what are known as the power rules. The power rules are essentially these 4 basic ones. There are 2 others that you may or may not have learned in the past, which we'll talk about this year. But these are the 4 basic rules. When you're multiplying 2 things that are raised to powers and they have the same base, you can add their exponents. And if you think about it, that makes sense. X squared times x cubed would be 2x's times 3x's, which would be 5x's times each other, so x to the 2 plus 3, which is 5. When you're dividing things that have the same base, you can subtract exponents. Again, look at the cancellation stuff that we did into fractions, like what we just did, and that makes sense as well. Now, we're not going to use the second 2 in the problem here, but they do exist as well. When you raise a power to a power, you multiply the powers. When you raise anything to the 0 power, it is 1. And except for 0. And we'll talk about why that's true later on in class. But I want to focus on the 2 rules that we're actually going to use in this problem, which are these 2. All right, so when you use these rules, what I'm going to do is I'm going to go ahead and multiply these fractions together, but I'm going to use the rules instead of having to write all that stuff out. So 18 is just a plain number. There's no other numbers on top to multiply it by. Then here I have x squared and x to the 4th. Now remember, the power rules only apply if the bases are the same. So x squared times x to the 4th would be x to the 2 plus 4, which is x to the 6th. And then that y on top is just by itself. Now, on bottom, same idea. We've got the 3, which is the only number you see. We've got x to the 3rd times x. Now keep in mind, x by itself is a power of 1, like that y on top was a power of 1. So x to the third times x to the first will be x to the 3 plus 1, which is x to the fourth. And then I have y to the 3 times y to the 6, which is y to the 9th. So now I can look and start doing this division rule. Now, you can do the division rule where you always do top minus bottom. The way I like to do it is this way. First of all, 18 over 3, those are numbers. They're not being raised to powers, so the power rule doesn't apply. That's just 6 over 1. It simplifies like a regular fraction. X to the 6th over x to the 4th, the bigger number is 6, so x to the 6th over x to the 4th would be x to the 6 minus 4, which is x squared. Now, if I were to do the y's, y to the first divided by y to the 9th is y to the 1 minus 9, which is y to the negative 8th. There is a meaning for negative exponents, and we'll talk about that a little bit later. But I think the easiest way of doing this is whenever you're using the subtraction rule, take whichever number is the bigger power, in this case that would be y to the 9th, and do bigger minus smaller, so 9 minus 1, which is 8, y to the 8th, and that would go in the place where the bigger power came from. So in this case, the bigger power was on bottom, so I'd end up with y to the 8th on bottom. And you see we get the same answer as we did the long way, but it took a lot less work. We'll be doing more work with those power rules a little bit later on, but it's really good to be familiar with them right now.